It's 1 in the morning, but if you're hungry for some supper, instead of ordering fried chicken or late night snacks, how about you go ahead and find solutions to radical equations? Solving radical equations, super simple. Let's take a look at the first example. Square root of x plus 3 equals 12. So that means square root of x must be 9, which means x must be 81. There you go. And number 4, we have 2x minus 3 raised to the power of half plus 2 equals 2. So let's go ahead first, get rid of that 2. So that means 2x minus 3 raised to the power of half equals 0, which means 2x minus 3 is essentially just 0, right? So that means x equals 3 over 2. Easy peasy, lemon squeezy. And then we move on to number 7. We have 7 minus square root of x minus 4 equals negative 6. That means negative square root of x minus 4 must be negative 13. Which also means square root of x minus 4 is 13. And that means x minus 4 must be 13 square, which is 13 square plus 4, which is 153. So moving on to number 10, we have a cube root of x plus 1 equals negative 2, which means cube root of x equals negative 3, and that means x equals minus 27, because minus negative 3 raised to the power of 3 is negative 27. I should really get a Botox over here. You can kind of see my wrinkle. Oh no. Anyway, going back to radical equations, number 13, x plus 1 raised to the power of 1/3 minus 2 equals negative 6, which means x plus 4 raised to the power of 1/3 is negative 4. And that means x plus 4 is negative 4 raised to the power of 3. So that means x plus 4 equals negative 64, which makes x to be negative 68. And moving on to number 14, we have negative 2 times cube root of 2x plus 5 plus 7 equals 15. So let's work our way from the most outer side. So that means negative 2 times cube root of 2x plus 5 equals 8. That means cube root of 2x plus 5 equals negative 4. And that means 2x plus 5 must be negative 64. So, and then that means 2x equals negative 69. So x is negative 69 over 2. I have fat cheeks. Maybe I could take my fat from my cheeks and inject it right over here. Do you think that's gonna work? Number 19, we're moving on to x raised to the power of 5 over 3 equals 243. So I'm going to vectorize 243, and it turns out 3 raised to the power of 5 gives us 243. So that means root of x raised to the power of 5 is 3 raised to the power of 5, which means x raised to the power of 5 is just 3 raised to the power of 5 that is also raised to the power of 3. So that means x equals 3 raised to the power of 5 times 3 over 5, which makes it 3 cubed, essentially 27. Take a look at number 21. 2x and x is raised to the power of 5 over 3, and that equals to 64. So that means x raised to the power of 5 over 3 equals negative 32. That also means x raised to the power of 5 equals negative 32 cubed. And just like what we did with the previous question, we can go ahead, break down, factorize 32. And what we are gonna end up getting is 2 raised to the power of 5 gives us 32. But in our case, we have negative 32. So that means negative 2 raised to the power of 5 gives us negative 32. And that negative 2 raised to the power of 5, that whole thing has been cubed. And since we have x raised to the power of 5, that means we're essentially going to have x equals negative 2 raised to the power of 5 times 3 over 5. And by times, I mean multiplication between the exponents, which essentially makes it x equals negative 2 cubed, which means x equals negative 8. And you can go ahead, verify this by literally substituting negative 8 into where x is. Now we're going to move on to question number 25. We have square root of x minus 3, and the whole thing, square root of x minus 3 equals square root of 2x minus 7. And you know what? We can square both of them, right? And essentially what we're gonna, since they're equal to each other, remember, as long as they're equal, whatever we do to one side, we gotta do the same thing to the other side. So that means we have x minus 3 equals 2x minus 7, which just gives us x equals 4. Very simple. Same thing with 27. We have cube root of 4x minus 9 equals cube root of 2x minus 4. So we can just go ahead, cube both sides since they're equal to each other, which means I'm gonna have 4x minus 9 equals 2x minus 4, giving x equals 5 over 2. And number 29, we have square root of x plus 1 equals square root of 3x minus 3. Now, what I'm gonna do is, since they are equal to each other, I'm gonna go ahead square everything, which means I'm going to have square root of x plus 1 square equals 3x minus 3, which gives us x plus 2 square root of x plus 1 equals 3x minus 3. And that we can go ahead, combine like terms, and we get 2 times square root of x equals 2x minus 4, which then gives us x squared equals x minus 2. And I'm gonna go ahead, square both sides again, and I get x equals x squared minus 4x plus 4, which means 0 equals x squared minus 5x plus 4, and bringing what we know about solving quadratic equations, we know that 0 equals x minus 1 times x minus 4. That means I have 2 solutions, x equals 1 or x equals 4. And now what we have to do is we're going to go ahead, substitute both potential solutions to the original equation way before we were squaring everything, and see if we get if the original statement, square root of x plus 1 equals square root of 3x minus 3, is solid. So let's go ahead. When I substitute x equals 1, what I end up getting is square root of 1 plus 1 squared. Oh no, I realized I shouldn't have squared it. Square root of 1 plus 1 gives us 2, and 2 equals 3 minus 3, which is not true. So this is extraneous solution. That means it's a solution that we ended up getting from the process of removing or eliminating radical components, but are not actually valid solution to our original equation. When we substitute x equals 4, the equation is valid, so therefore this is our true solution. And let's take a look at number 30. I have cube root of 3x plus 9 equals cube root of x plus 6. So I'm going to go ahead, cube both sides, and I get 3x plus 9 equals x plus 6. And that means 2x equals negative 3. That means x equals negative 3 over 2. And let's take a look at number 31. I have x plus 2 equals 2x plus 7. So again, in order for me to eliminate that radical portion, which is square root of 2x plus 7, I'm going to go ahead square both sides. And what I end up getting is x plus 2 squared equals 2x plus 7, and x plus 2 squared can be expanded to x squared plus 4x plus 4. That is equal to 2x plus 7. So that means x squared plus 2x minus 3 equals 0. This equation can be factored to x plus 3 times x minus 1. So right now we have two potential solutions, and we need to go ahead check for extraneous solutions by substituting x equals negative 3 and x equals 1 and see if our original equation is valid. So when I go ahead substitute x equals negative 3, I get negative 1 equals 1. This is not valid. This is extraneous solution. And when I go ahead when I substitute x equals 1, I get 1 plus 2 equals square root of 2 plus 7, which makes this solution the valid solution. And negative x equals negative 3 is our extraneous solution. So these videos wrap up chapter 3. I hope they were not as challenging to go through. Please try the rest of the questions in your workbook, and we'll go over any questions that you might have from this chapter and review them when we see each other in person. I hope you have the most wonderful rest of the holiday, and Happy New Year, and I love you guys very much. Bye.